All right. Hi, everyone. My name is René. I'm a freelance software engineer, and I'm very, very happy to be here today to share my experience about full stack development with you. And today it's going to be all about full stack development of single page applications using Spring Boot and React, and how we can make this development as efficient and productive as possible. When I started to use React in web development, I was quite familiar with building a suitable backend using Java and Spring Boot. But building the React frontend was kind of new to me. And every time I use a new library or framework, over time I usually reach new levels of productivity, and usually my code base becomes more and more maintainable. And I actually experienced the same when I was building single-page applications with Spring Boot and React. And looking back, I've discovered 6 levels of maturity that I want to show you today. And I hope you can use some of my learnings for your current or maybe for your next project. I would like to walk you through these 6 maturity levels based on a simple task application. It has a master and a detail view, and it provides basic CRUD operations. And on the following slides, I'm going to show you how to develop this app, starting at level 1 and reaching level 6 at the end. Alright, so let's start developing the simple task application, and I will start with the backend. As a Java developer, I'm used to start building web apps from the backend. And this is a very typical layered architecture for a simple web app like our task application. We have a database to store our tasks. We use an entity and a repository as a data access layer. There is a service that will handle the pretty simple business logic of our task app. And finally, we have a presentation layer with a controller that provides the necessary HTTP API to a consumer, which is, of course, the React frontend of our simple task application. When I build a Spring Boot-based backend like this, I usually start with a Spring initializer. For the backend of the simple task application, I use some common dependencies, like, for example, Spring Data JPA and validation for my data access layer, and Spring Web for my presentation layer. I'm not going into the implementation details of the backend here, because I assume that most of you are very familiar with Spring Boot and how to create such a backend. And that said, let's jump straight into the frontend at level 1. There are, of course, different ways to start a new React project, and I decided to use Vite, because to me it has become the de facto standard. So Vite is a very popular build tool for front-end development, and among other things, it consists of 2 major parts, a bundler and a dev server. And fortunately, Vite also supports scaffolding new projects with templates for various frameworks and libraries, including React. So to create the front-end part of the example application, I can run these commands. And after installing the required dependencies and starting Vite's dev server, I can access the generated sample application. And now it's actually time to adjust the generated code and to create the front-end of the simple task app. The structure of the front-end project looks like this. To enable a simple routing between the master and the detail view, I install and use React Router. I use React Router's data mode for the router configuration. So there is a tasks route that points to the tasks view, which is the master view containing all the tasks. And there is a route that points to the task view, which is the detail view of a single task that is identified by its ID. React Router has a concept called loaders to fetch data from a backend. In the simple task app, there are 2 loader functions. One to load all the tasks from the backend, and one to load a specific task by its ID. For data mutations, React Router has a concept called actions. And the action in the simple task app is split into 2 sections. It can handle the creation of a new task as well as the update of an existing task. Finally, let's have a quick look at how to display the data in the frontend. Here you can see the tasks view component that displays all the tasks in a grid. I use the associated loader to fetch all the tasks from the backend. I map over the tasks array and create a table row for every task, or I just show an info when no tasks are available. Alright, so that is the first iteration of the simple task app. So where are the problems, where are the gaps between the front end and the back end at this point? Well, one of the biggest problems here is that there are no type information about the business object in the front end, neither at development time nor at runtime. Although we know how a task is defined in our backend, we are losing all the type information between the backend and the front end. And this actually makes development quite slow and error-prone, because our IDE cannot support us with things like auto-completion or static code analysis. And of course, there are plenty more disadvantages at this stage, and we will come back to them later. But for now, I want to focus on the biggest issue, the missing types. And therefore, I would like to introduce TypeScript to the front end and use it instead of JavaScript, because this way we can define types to make the development in the front end more type-safe. Fortunately, Vite also has a template for new projects that uses React together with TypeScript. This means we have to create a new project and migrate our existing codebase. And of course, we have to create a type that represents our business object in the front end. I can now use this new type when I migrate my JavaScript code into TypeScript code. I can add it to the existing loaders to specify that the loader for all tasks will return a promise with an array of tasks or null, and that the loader for a single task will return a promise with a task or null. The same applies when we use the loaders in the corresponding view components. We can now express that the loader in the tasks view will return an array of tasks, and that the loader in the task view will return a single task. With these changes in place, my IDE can now support me during development because it understands the types and can therefore provide things like auto-completions and show type errors. So that's level 2. But where are the gaps here? Well, the communication between the backend and the front end is still typeless. We made an assumption that we exchange data with the backend in a certain format, but we cannot be sure that our assumptions during development are always true when our single-page application runs in production. And in addition, the types disappear when the TypeScript code is transpiled to JavaScript. This means if the backend sends or expects data in a different format, we are currently not able to deal with this, and our application may behave in an unexpected way. So, for example, the list of tasks will remain empty, or submitting the form for creating or updating a task just won't work. So, looking at the previous disadvantages, let's move our frontend to the next level. And to make our single-page application more robust against unexpected data, we can add a runtime validation of data that is passed from the backend to the frontend. And one option to achieve this is introducing a library called Zot to our frontend. So Zot is a TypeScript-first schema declaration and validation library. We can use it to create a so-called Zot schema for our business object. And we can use this schema to validate data against this schema at runtime. And in addition, Zot can automatically infer the static TypeScript type of a schema, which means we don't have to declare schemas and types separately. Alright, so let's add Zot to the frontend by installing the corresponding npm package. Next, I can create a Zot schema that describes my business object. And as you can see, I declare the task schema as an object. So each field is defined with its corresponding data type and additional validation information. With the new task schema in place, Zot can automatically infer the task type, which means the type definition becomes very easy and maintainable. We can now use the task schema to validate the data the front end receives from the backend. For example, after fetching all the tasks from the backend, we can now check whether the received data is an array of task objects or not. The same mechanism applies when I fetch a specific task from the backend. I can use the task schema to check whether the received data is a valid task or not. And in case the data is not valid, we can now explicitly handle this circumstance. Alright, so now we have type safety at development time and at runtime. And in terms of developer experience and error handling, we made some progress compared to level 1, which means the gap has become smaller. but there is still a lot we can improve here. For example, at the moment I have to make sure that the sort schema and the inferred type matches with my business object in the backend. Until now, this is a manual and error-prone process. It might be okay for a single dev with a small code base, like in our simple task app, but it will become a problem when the team and the code base is growing. One approach to solve this problem is to generate the sort schema for the front end based on a schema of our backend. And for a Spring Boot based backend, this can be achieved with the help of OpenAPI, formerly known as Swagger. I think most of you are already familiar with OpenAPI. It's an initiative under the sponsorship of the Linux Foundation, and it develops a machine-readable interface definition language that we know as OpenAPI specification. And developers can use the OpenAPI specification to describe and visualize their HTTP APIs. To use OpenAPI in my Spring Boot backend, I can add this dependency to my POM.xml. And that's actually enough to create an OpenAPI specification of the HTTP API of my backend. And when I restart my backend, I can browse my API using the so-called Swagger UI. It shows all the endpoints, the available operations, and I can use and test them directly in the browser. And fortunately, OpenAPI also provides the OpenAPI specification as a JSON or YAML file, and we can use this file to generate code from it. Based on this OpenAPI spec, we can generate a TypeScript API client together with a sort schema, an inferred type, and runtime validation. One way to achieve this is by using the npm package OpenAPI sort client from Alexandros Damer, which we can install like this. And now we use the OpenAPI spec of our backend as an input for the installed package, and we define the target for the generated client. Running the second command will generate a fully functional TypeScript API client based on Zodios and the OpenAPI specification of our backend. Using the generated client, we can now simplify and adjust our code for the backend communication. For example, loading all the tasks is now done using the generated getTasks function. To load a single task by its ID, we can now use the generated function getTaskById. The generated API client also contains functions to create, update, and delete a task, and it implements a brief error handling when runtime validation fails. Alright, so that was already level 4. Thanks to the OpenAPI spec and the generated API client, the gap between the front end and the back end has become smaller again. We can now maintain our business object in the back end and generate the required client-side code for the communication. But as you can imagine, there is still room for improvements. At the moment, the API client must be regenerated manually when we change our business object in the backend. And it would be nice if our toolchain could actually do this automatically for us. And regarding the toolchain, the front end and the back end reside in two separate projects at the moment. Although they are tightly coupled now, based on the OpenAPI spec as their contract, it is not yet possible to build and deploy them together. And this brings me to the next piece that deserves some improvements, the toolchain itself. As I said, the backend and the front end are two separate projects, each with its own solution for dependency management, build tooling, and configuration. And this might be okay if the backend and the front end are developed by separate teams, but in terms of full stack development, it is not very ideal. So what can we do to simplify the toolchain? I would like to focus on two things here. I would like to set up a Maven multi-module project to be able to simplify the build process, and I want to be able to deploy the backend and the front end together as one unit, for example, as an executable jar file. To establish a Maven multi-module project, the code of the simple task app will be organized like this. There is an overarching Maven multi-module project. There is the backend module containing the Spring Boot based backend, and of course there is the frontend module containing our React frontend. The POM.xml in the frontend module configures the so-called frontend Maven plugin from Eirik Sletteberg, and this plugin automates and simplifies the build of the frontend. It takes care of things like installing Node and NPM if they are not yet available, installing all the required front-end dependencies, generating the API client based on the latest OpenAPI spec of our backend, and bundling the frontend using Vite. The POM.XML in the backend module will be enhanced with the Maven Resources plugin. The plugin will copy the generated frontend bundle to the static directory on the build target folder of the backend. And this will ensure that the Spring Boot backend will automatically serve the frontend bundle when the backend is started. And with these changes in place, we can now package our application as an executable jar file. And this jar file, also known as fat.jar or uber.jar, contains the compiled backend code, all the required backend dependencies, an integrated servlet container, and the frontend bundle. And if I now run the executable jar file, the integrated servlet container will serve the Spring Boot backend as well as the React frontend as a static resource. And these changes actually simplify the build and deployment of our simple task application. And we can now manage our application in a simple monorepo with a unified build command and the ability to release the backend and the frontend together as one single deployable unit. Alright, so that was level 5. And as you can imagine, there is still so much more we can do, especially from a user perspective. Until now, we have no data validation on the frontend when users create or update a task. We cannot do things like filtering, sorting, or pagination in the task grid. And we still have a lot of boilerplate code to support the simple CRUD operations, especially in our backend. And it would actually be nice to add a better user experience to our simple task application and to increase the developer productivity even further. But how could we achieve this? Which path should we take to move our code base to the next level? Well, we could add more libraries to the front end to achieve things like data validation, sorting, filtering, and pagination. And we could try to refactor our backend code to be more generic and to avoid some of the boilerplate code. And these are actually all valid options, and continuously optimizing the code base and the toolchain of a full-stack web app might even be the best approach if you want to have everything under your control. But there are alternatives, because we don't have to reinvent the wheel every time we try to reach a higher level of productivity and maintainability. One alternative is to look at code generation approaches like JHipster or Bootify, for example. And while they are a great starting point for new projects or prototypes, I think they do have some disadvantages in terms of productivity and maintainability on the long run. Another alternative are full-stack frameworks. Of course, there are plenty of full-stack frameworks for web development out there, and choosing the right one heavily depends on your app, your requirements, and your experience. And today I'm not going to talk about popular React frameworks like Next.js, Remix, or Nest.js, because as a Java developer, I want to keep Spring Boot as the foundation for my backend. So I'm actually looking for a full-stack framework to develop web apps using React and TypeScript in the front end and Spring Boot and Java in the back end. And fortunately, there is such a framework, and it is called Hilla. So let's have a brief look at Hilla. Hilla is an open source framework from a company called Vadin. It combines Java and Spring Boot in the backend with TypeScript and React in the front end, following the backend for front end pattern. And Hilla aims to provide a seamless integration between Spring Boot and React with an end-to-end type safety at development time and at runtime. And Hilla tries to achieve this by continuously generating a TypeScript client and associated types for a type-safe communication between the backend and the front end. Under the hood, Hilla uses OpenAPI to achieve this, but as a developer, I don't have to deal with the technical implementation details of this. Alright, so let's use Hilla to implement our simple task application. We can create a new Hilla project, for example at start.vadin.com, or using this simple CLI call. Our created project has this structure here. We have a front-end folder for our TypeScript and React code, and a Java and resources folder for our backend code. And in addition, we see a lot of familiar files and folders for things like Maven, Node modules, TypeScript, and Vite config. but compared to the previous levels, Hilla simplifies the toolchain of our simple task application. The dependency management and build configuration are handled by Hilla using either Maven or Gradle. And Hilla also takes care of bundling the front end using Vite. If we start our generated Hilla app at this point, we will see this UI. Hilla provides a solid app layout and a nice default theme as a starting point. And it also supports things like file-based routing based on React Router, which makes it easy to implement a master detail view pattern, for example. So let's have a look at the data access layer of our Hilla project. The code of the task entity is actually very similar to the existing code of the Spring Boot backend from the previous levels. We only add some Jakarta bean validation annotations that Hilla will use for its built-in data validation capabilities. The task repository extends the well-known JPA repository interface and the JPA specification executor interface, which adds functionality for the JPA criteria API. This enables Hilla to provide things like pagination, filtering, and sorting, which will we use for the task grid in our master view in a minute. However, the biggest change in the backend code compared to the previous levels takes place on the business logic and presentation layer. With Hilla, we don't need to implement the CRUD functionality in a service and a controller. Instead, we use this simple service that extends an existing CRUD repository service that Hilla provides for us. Hilla also provides a browser callable annotation. And thanks to this annotation, the task service will be exposed to the front end, and Hilla will generate the required TypeScript code for the communication between the backend and the front end. So compared to the previous levels, we now have 10 lines of code instead of roughly 150 lines of code. Let's have a look at the front end. In the master view, we use the so-called AutoGrid UI component from Hilla. It provides things like sorting, filtering, and lazy loading out of the box. The AutoGrid component uses the auto-generated task model and task service. Hilla generates these files based on the task entity and the task service we implemented in the backend. And Hilla also takes care of updating the generated code when we change something in the corresponding code in the backend. The detail view of our simple task application uses the so-called AutoForm UI component from Hilla. Hilla infers the task type to select appropriate UI components, like for example a text field component for the title attribute of a task, which is a string, or a select component for the status attribute, which is an enum, and a date picker component for the due date, which is obviously a date. So this means that the AutoForm component also uses the auto-generated task model and task service. And Hilla also takes care of all the validation and the communication between the front end and the back end when a user submits the form component. Compared to level 5, we save a huge amount of code, and at the same time we gain a lot of additional functionality for our simple task application. So using a framework like Hilla can definitely help us a lot, but it certainly has some disadvantages. Whenever you use an opinionated framework to gain productivity, you have to accept a certain level of abstraction and a certain loss of control. Using a framework also means you have to understand and adapt its concepts to use it the right way. And although a framework like Hilla is open source and imposes little to no barriers, you tie yourself to a framework and the company that maintains it. In the end, it's another bet, like you bet on Spring Boot and React. Alright, so we reached the highest maturity level 6. There are still some disadvantages left and we still have room for improvements, but I think we made quite some progress. To summarize the way from level 1 to level 6, let's have a quick look at this table. So we started without any types, and we added type safety at development time using TypeScript and at runtime using Zot. We achieved end-to-end types and a generated API client using OpenAPI and Zordios. We simplified the toolchain using a multi-module project and a unified build configuration. And finally, we made a big step forward in terms of productivity and functionality using a full-stack framework like Hilla. Okay, so that's it. I hope you enjoyed the talk and you learned something new today. Thank you very much for your attention, and a big thank you to the organizers of this event. If you have any questions, please share them in the comment section or just reach out to me later. Thank you very much and have a nice day. Bye bye.